Today we'll be solving equations with variables on both sides and talking about types of solutions. Basically, we've been solving equations and having one solution, meaning x is equal to this or x is equal to that. But those are not the only cases. We also have times when you may have no solution or infinite solutions and infinitely many solutions. So, an example of one solution, 3 times 2x plus 9 is equal to negative 5 minus 3x. So in order to solve and isolate x, I first need to distribute. I need to distribute 3 inside my parentheses. So 3 times 2x, 6x. 3 times positive 9, 27. Now I have a nice equation with variables on both sides. I'm going to remove my negative 2x from this side because I want it on the other side of my equation. And the only way I can do that is by doing its inverse. The inverse of subtracting 2x is adding 2x. And if I add 2x to one side, I must add 2x to the other side. Well, 6x plus 2x gives me 8x. Bring down my 27. Bring down my negative 5. And negative 2x plus 2x are opposites, so they cancel. Well, now I need to get this positive 27 on the side with the constant because I don't want it over here with my variable. The only way I can do that is by doing the inverse. The opposite of adding 27 is subtracting 27. And if I subtract 27 from one side, I must subtract 27 from the other side. Well, bring down my 8x. 27 minus 27 cancel. And negative 5 plus a negative 27 equals a negative 32. Still trying to isolate x. Now it's being multiplied to 8. So the opposite of multiplying by 8 is dividing by 8. 8 and 8 cancel, and x is equal to a negative 4. This is an example of one solution because I can substitute this negative 4 back into my equation for x, and it will be true. So this is an example of one solution. Well, what about an example of no solution? I won't necessarily know it's no solution until I actually solve it. So 7x minus 9 minus 3x is equal to 4 times x plus 3 plus 1. I need to distribute. So 7x minus 9 minus 3x is equal to 4 times x and 4 times 3. If you notice, I have like terms on both sides of my equation. I have like terms with 7x and negative 3x. And then I have like terms with positive 12 and positive 1. So I need to combine my like terms. So 7x minus 3 gives me 4x. And 12 plus 1 gives me 13. Now I have a nice equation with variables on both sides. So I'm going to move my constant on the other side of the equation. And the only way I can do that is by doing the inverse. So the inverse of a negative 9 is adding 9. And if I add 9 to one side, I must add 9 to the other side. Well, I'm going to bring down my 4x. Negative 9 plus 9 cancel out. Bring down my other 4x. And 13 plus 9 is a 22. Well, now I need to move my variable on the other side of the equation. So I want to move 4x to the other side. The only way I can do that is by the inverse operation. The inverse of adding 4x is subtracting 4x. But something different happened. I have 4x minus 4x. That means they're all gone. So that equals to 0. And on my other side, 4x minus 4x, they're still gone. And I'm only left with positive 22. Is this a true statement? No, 0 does not equal 22. It never will. So that's not true. So because it's not true, my answer is no solution, because no number that I will plug into for x is going to make that solution true. And we usually do this by saying no solution. So since 0 is not equal to 22, the answer is no solution. All right, in our last example, infinite many solutions. Negative 2 times 3x minus 5 is equal to 2x plus 10 minus 8. So distribute first. And I get negative 6x plus 10, because negative 2 times 3 is negative 6. Negative 2 times negative 5 is a positive 10. On my other side of the equation, I got a couple of like terms. I have 2x and a negative 8x, so I can combine those. Negative 2 minus 8 is negative 6. All right. I want to move my variable to the other side of the equation, and the only way I can do that is by doing this inverse operation. So the inverse of subtracting 6x is adding 6x. If I add 6x to one side, I do it to the other side. But something funny happens again. I have negative 6x plus 6x. That means they cancel out. Bring down my 10. Now I have negative 6x plus 6x again. They're opposites, so they cancel out. Bring down my 10. Does 10 equal 10? All day, every day. This is a true statement. Therefore, it doesn't matter what number I plug in for x, it'll give me the same number. So this is what we call infinitely many solutions. And we usually do that with a symbol, like an infinity symbol. That's a kind of janky infinity symbol, but. And if you have any questions about the lesson and still need extra help, you can ask me in class.